Hello guys, welcome to the second video on fundamentals of mathematics. The first video, which we call day 0, was about the rundown of this video series, and we said this series is going to be made up of 8 units, and here today is the first unit, which is talking about number properties. In today's video we are going to be talking about the commutative and associative property, and at the end of this video we are going to have a quiz that will test your knowledge acquired through this video. So stay tight and watch till the end. Stay with me on It's Math Time Questions and Answers, a channel that gives you insights about the problems giving you headache at school. Without much ado, let's look at the properties in details. So the first property which we'll be talking about is the commutative property. In this property we are going to demonstrate these properties using examples so that we can better understand them. So take for instance that we are adding 3 plus 7. What is the answer? 10. If we also decide to change the order of addition and rather add 7 plus 3, we will still have an answer of 10. Let's look at a next example, which is minus 1 plus 5 will give us 4. What if we change the order again and instead perform 5 plus minus 1? This is also going to give us an answer of 4. Therefore, from these two examples, we can see that no matter the order in which we perform an addition, the result will still be the same, because 3 plus 7 is equals to 7 plus 3, and also minus 1 plus 5 is equals to 5 plus minus 1. Then we can conclude that no matter the order in which we perform an addition, the result is the same, and we call this property the commutative property of addition. Let's look at what about something like multiplication. Let's look at multiplication. Let's take for instance 6 times 2. The result is 12. What if we decide to do 2 times 6? 2 times 6, the result is as well 12. Please take note, the dot here is not a point. We use the dot here for multiplication. You can use the normal multiplication we use, or you can use bracket. Just for typing, to make typing easy, I decided to select the dot. So please, it's not a point. Okay, so since we have seen that 6 times 2 is 12 and 2 times 6 is as well 12, then we can conclude that the order of multiplying 2 numbers or 3 numbers or whatever numbers we have, the order in which we perform this multiplication does not matter, because 2 times 6 is the same as 6 times 2. Then we can say that the operation commutative, which says that we can call this property the commutative property of multiplication. So what about the other operations? Are they commutative? Like subtraction? Let's see. So when we perform the operation 5 minus 9, what's the result? Minus 4. What if we change the order of the operation and we carry out 9 minus 4? Will it still give us minus 4? No, it will give us 4. Minus 4 is different from 4. So we can conclude that 5 minus 9 is not the same as 9 minus 5. Therefore, we say that what? We should be careful when we are performing operations with subtraction, because the order in which we perform these operations matters, because subtraction is not commutative. So the order will matter. So that's why we, in the next unit, which will be unit 2, will help you tell you about the order of operation. With this video, let's stick with the properties. What about the operation with division? For instance, 14 divided by 7. 14 divided by 7 is 4. But what about 7 divided by 14? 7 divided by 14 is a half, or what we call 0.5 in decimals. So we can see that since 14 divided by 4 is not equal to 7 divided by 14, then we can conclude that 14 divided by 7 and 7 divided by 14, since they are not equal, the division is not commutative. So we should be careful when dealing with what? Division, because the order of operation matters. Therefore, we can use this knowledge that we have gathered here to summarize the commutative property of addition, subtraction, division, and multiplication on the table below, which the first column talks about operation, the next talks about commutativity and a reason why we should accept whether it's commutative or not. So the first operation we are talking about is addition. And addition, is it commutative? From the example we have seen, yes, it's commutative. Why is it commutative? Because A plus B is equals to B plus A. The order in which we perform this addition doesn't matter. What about the next operation? We talk about subtraction. The subtraction, we are going to is subtraction commutative? No, because A minus B is not the same as B minus A, as we have seen in the case of 5 minus 9 not equals to 9 minus 5. What about the other operation? Multiplication. Multiplication, is it commutative? Yes, it is, because we have said that A times B is the same as B times A. What about the last operation? Division. We have said division is not commutative. So in summary, when we are dealing with addition and multiplication, the order in which we carry out the operation doesn't matter, because the operators are commutative. When we are talking about division and subtraction, the order in which we carry out the operation matters, because these operators are not commutative. So let's look at the next property that has to do with associativity. So for us to consider associativity, again, we are going to look at example. Let's take three numbers for examples: 5, 7, and 3. Let's add them. There are several ways in which to perform this addition. Some people might decide to add 5 plus 7, take the results and add it to 3. Some may decide to add 7 plus 3, take the result and add it to 5. Some may decide to add 5 plus 3, take the results and add it to 7. But if we perform this operation in different ways as we have seen, will it give us the same answer? If it gives us the same answer, then we can say that what? Addition is associative. So in this video, we'll just take two different ways to add this equation on the board. So some people may decide to add the first two, which is 5 plus 7, as most people will do, and will give us a result of 12, and then they will take this result of 12 and add it to what? 3, to give us a result of 15. Now let's look at what other people may do. Some people may quickly consider and see this operation that if you add 3 plus 7, it will give you 10, and you take this result of 10 and add it to 5, will give us again 15. Therefore, since the order in which we perform, the grouping, the way we group these operations does not matter, because it will give us the same result, then there we conclude that what? Associativity is addition is associative. So in that sense, we can say that since 5 plus 7, that result plus 3 gives us 5 plus 7 plus 3, we can conclude that the addition is associative, and this law is called the associative property of addition. So in commutativity, we deal with the order in which we perform them does not matter, but in associativity, the grouping of addition does not matter. You can group the numbers anyhow and perform the addition, it doesn't matter. What about multiplication? In multiplication, we have 10 times 2 times 4. Other people may decide to group 10 times 2, then you perform the result, which is 20 times 4, which is 80. Other people may decide to do 4 times 2, then the result, which is 8 times 10, which is still 80. Then we can see that if we are performing multiplication, the grouping doesn't matter as well. So we can say that what multiplication is commutative because the way we group the numbers before we multiply does not matter. So in this case, we can say that what addition and multiplication are both commutative because the order in which we perform them does not matter, and they are both associative because no matter how we group numbers before we perform the multiplication or addition will give us the same results. So you may be familiar with this rule, but to most of you the terms associativity and commutativity might be new, and we need to know them when we are talking about mathematics. So in conclusion, with the law of associativity, I want you to verify if subtraction and division are associative. So in the next slide, we are going to see the general rule. In general, for associativity, that is associativity for addition and multiplication, we can say that associative property of addition is considered if A, B, and C are real numbers, then A plus B plus C is equals to A plus B plus C, meaning the order in which we perform them, the grouping, the way in which we group them doesn't matter. Remember, brackets in mathematics are used to group numbers, that is to indicate which group of numbers to perform first, then the next. In the next case, for multiplication, we have also said that if A, B, and C are real numbers, then A times B, the result, times C is equals to B times C, the result, times A. So the grouping doesn't matter. So guys, that is the associative property and the commutative properties of numbers and operations. So in the next slide, we are going to have a quiz, and don't forget to give us answers to this quiz on the comment section. So pause the video, answer this quiz, and give us the answer on the comment section. We'll evaluate by telling you if you are right or wrong, and then you try again. So guys, thank you for watching and stay with me. Remain blessed. Bye bye.